form is this in? Okay, so I thought this might be a problem that we were having. It should be obvious, and I'm about to make it really obvious for you, Quadratic. There are three options. Your options are standard, vertex, or intercept. How many parentheses are there in standard? How many parentheses in vertex?
1.
How many in intercept?
2.
Okay, so look at problem number 1. How many parentheses are there in it? So what form is it in?
Standard.
Look at the whole front page. Are there any parentheses in any of those problems?
9.
The whole front page will be in standard form. So I would make a note at the top of the front page, all these are in standard. Something like that, right? So that you'll remember. And tomorrow on the test, they'll be the same way. That means 1, 2, 3, and 4, you work them the exact same way. Every single one. You do the same procedure. So I don't mind if you guys ask questions. In fact, I want you to. But please try to keep the conversation to a minimum because my other classes are going to use this video too. So I want to make sure that, you know, don't hesitate to ask questions, but try to keep all the conversation down, please. Okay, so I need to find the vertex first. Does anyone remember how to find the vertex if it's in standard? There's a formula for that.
Have a B in it?
It does have a B in it.
B equals...
No, what is it?
B over 2 times A.
Close.
Negative
B over 2A. You got to memorize that formula. The only three I'm giving you are these three. So you will need that one, okay? X equals negative B over 2A. So we're going to plug in. Remember, A is the number attached to x squared. B is the number attached to x. C is the constant. So what's B in this problem?
0.
Good. There is no B. There's no x term. There's an x squared term, but that means this number is A. B has to be attached to a plain x, no square, nothing, and there's not one. So that means B is 0. So I got this negative 0 on top. And then on the bottom, 2 times A. Well, A is a half, so I'm going to plug in a half for A. Well, I'm not even going to bother doing 2 times a half, because I already know what this equals. What does it equal?
Yeah.
It equals 0. I got a 0 divided by, I don't care. I don't care what's on the bottom. As long as it's not 0. If it was 0 on the bottom, it'd be undefined. But 0 divided by anything except 0 equals 0. Okay, I need to find the y value for my vertex. I found the x, I need the y. How do I do that? Anytime. This applies anytime I have an x and I want a y. How do I accomplish that?
Plug in.
Plug in where?
The X.
In the original function, right? Come back up to the function and plug in 0 for x. That's what the function is for. You give it x's and it tells you the y that goes with the x. So I'm going to give it an x value. I'm going to plug in 0. And I'm going to see what that equals. I don't even have to work it out. What does it equal?
0.
0, right? This is going to be 0. Okay. I know the vertex is at 0, 0. Everybody with me so far?
Yes.
Okay. Now I need to pick the other points. So I pick the first 2 x values to the right and the first 2 x values to the left. So if I'm at 0, what are the first 2 to the right?
1, 2.
1 and 2. And if I go to the left, what are they?
-1.
Excellent. All right, so now I just need to figure out the y values. Well, I did the same thing I did before to find the y value. Plug them in. So I have 1/2 times 1 squared. What is that going to give me? Well, let's see. What is 1 squared?
1.
And what's half times 1?
0.5.
A half. Yeah, 0.5 or a half. You can write it either way. I'm going to write it up here as 0.5 just because that's the way that the graph is labeled. Right? It's labeled with decimals. Okay, so that means I know that what other number has a 0.5 for its y value?
-1.
Good, because of the symmetry, right? Okay, so now I need to see what happens when I plug in 2. So I got 1/2 times 2 squared. What's 2 squared? 4. What's half of 4? 2. So I plug in 2 and I get 2, and that means if I plugged in -2, also going to get 2 because of symmetry. Now all I got to do is graph it. So 1.5, -1.5. 2, 2, and -2, 2. 2, 2, -2, 2, connected dots. Of course, your graph will look different because your graph is scaled differently, right? But should be easier to graph on your graph actually than to graph on mine. Questions about that problem? No? Okay, cool. Number 2. I'm going to make you an offer on number 2. Nobody's gotten it all day. Does anybody need more time on this before I switch slides? Yes, sir. Say what? Were you not here Friday? I gave this out on Friday.
I think I turned it in.
I got it. Okay, I'm offering bonus points. If someone can tell me number 2 is a very special function. It is so special, in fact, that it has its very own name. And if you can tell me the name, I will give you 5 bonus points on your test tomorrow. That's all you got to do is tell me what it's called.
The name of number 2?
Number 2. That is a very special function.
Y equals x squared.
That's what I'm talking about. It's a very special function. I'll give you about 30 seconds and then I'll tell you what it is. But you got to know this, guys. We talked about it.
Oh, it's a parent function.
Remind me tomorrow to put +5 on your test. First person all day. Thank you. It is the parent function. It is the parent function for quadratics. That's why it pays to take good notes. It's the parent function for quadratics. Every other quadratic function, all of them, are this function with some transformations done to it, right? This is the default setting, number 2. So it should be really easy to graph. So let's graph it. So, f of x equals x squared. I'm going to do the same thing I did before. I'm going to start by finding the vertex. Now, some of you could probably figure out without doing the whole negative b over 2a thing, especially if you realize it's the parent function, it should be obvious where the vertex is. But you can always find it, if it's in standard form, by doing this, in case you don't remember. So, what is b? Is there an x term in this problem? Is there a regular x term in this problem? Should be an easy question to answer. No, there's not, right? There's an x squared term. So what does that make b?
0.
0. Over 2 times a. A is, what is a?
1.
1. Good. So I've had people before, if there's no number actually written here, tell me that a is x. No. A, B, and C will never be x's. Look at the formula. Here's the x squared. A is just the number in front of it. Here's x. B is not x. B is just the number in front of x, right? So what number is secretly in front of it? 1, right? Understood 1. Okay, but it doesn't really matter because what is all this going to end up being? 0. Very good. Right, so I got 0 here. And then it should be easy to tell what the y value is, because if I plug in 0, what do I get?
0.
Okay, so that was easy. It's at the vertex, right? That's the default setting for a quadratic function, for a parabola. It starts at the vertex. Then we might shift it or stretch it, but this is the default setting at the origin. Right? Okay, what are the 2x values to the right?
1 and 2.
Good. And to the left?
1, -2.
Excellent. And now I just plug these in. I'm not even going to bother writing it. It's so easy. What's 1 squared?
1.
So that's both 1. What's 2 squared?
4.
So these are both 4. So just got to graph these points. 1, 1, negative 1, 1, 2, 4, and negative 2, 4, and connect the dots. Boom. Questions? Stop me at any point with questions. Also, if I change slides and you still need time, just say something to me. Am I good to change it?
Yes.
Okay. So don't feel like you have to get the actual graph down, because your graph's not going to look like this anyway. Your graph's different. It's numbered differently. As long as you get the table of values, you hopefully should be able to graph those points yourself, right? Am I okay to change now? Just get the table of values. Try and copy as quickly as you can, because I want to make sure we get through this, and we're going to be pushing it. You got it? Okay, number 3. Still in standard form. Still going to do the exact same thing I've done every time. I'm going to start by doing the negative b over 2a to find the x coordinate of the vertex. Okay, so x equals negative b over 2a. What is b? 2. And 2 times a, what's a? Okay, so I am actually going to have to work this one out because that's not a 0 on top. So I would do 2 times 1/2 on the bottom. What's half of 2? 1. So I end up with negative 2 over 1, and that just equals negative 2. So there's the x value of my vertex. Plug it in. You got an x and you want to know why? Plug it in every time. So we got negative 2 squared plus 2 times negative 2 plus 3. Now, you can punch this all in the calculator at once. In fact, I would probably encourage you to do that. If you do it, I know I've said this before, and yet I still walk around the room and I see people not doing it. I'm sorry, Austin. Which it means you either have not been listening to me or you don't believe me. But you should do both those things. Listen to me and believe me, right? Because if you plug it in without the parentheses, your answer will be wrong on this problem. Okay? You have to use the parentheses.
It's 1.
It is 1. Negative 2 squared is 4, half of 4 is 2. This would be negative 4. 2 and negative 4 is negative 2, and negative 2 and 3 is 1. It is 1. So negative 2, 1 is my vertex. And then I do the same thing I did on the last problems. 2 points to the right, 2 points to the left.
1.
So I know some people occasionally have a hard time thinking of the points to the right and the left. It's kind of a weird thing for them. So think of the x-axis as a number line, right? And if I'm at negative 2, what would be the next point to the right? And then the next one to the right of that would be what? 0.
Negative
And then if I'm back at negative 2 to the left, I got negative 3 and what? And negative 4. Good. All right, so let's go ahead.
Is it okay? I'm sorry.
No, you're
Is
fine.
it okay if you use like different points for that? Or do you have to use them?
Okay, so you could use other points, but these are going to be the ones you want to use because as you choose points that are farther out, the numbers just get bigger and bigger. And so if you chose points that were too much farther out from that, they wouldn't fit on your graph. As long as they'll fit on the graph, I don't care if you use these 4 points or another 4 points, right? As long as they fit. So let's plug these in. So if we plug in negative 1, let's see what we get.
Wait, where's that?
You may have chosen other points to avoid getting fractions, I'm guessing maybe. And that would be fine, yeah. So what do I get when I do all this? Okay, well negative 1 squared is 1. Half of 1 is a half. 2 times negative 1 is negative 2. A half plus negative 2 is negative 1.5. Negative 1.5 point plus 3 is 1.5. You should verify that you can get that in your calculator. I'll give you a second. It's that important to me. Because I know you're going to use them tomorrow. And I think that you guys have a tendency to assume that if the calculator says it, it must be true, right? The calculator is only capable of doing what you tell it. So we need to practice to make sure that we can actually input these things the correct way to get the correct answer. I see some people that don't have calculators on their desk. Do you plan on not using a calculator on the test tomorrow? You should get your calculator. I'll give you a second. You should practice with the calculator. You don't know if you're going to get it right or not if you don't practice, right? So I would get the calculator out.
Walk of shame.
Section.
Yeah. Hey, I have a question. Can
Yes,
you
ma'am.
stop turning around? So I don't want to be in your video on YouTube.
Yeah, just film me or the board. Thank you.
Because I don't want to.
Okay, so let's plug in 0, because plugging in 0 is easy. What do I get when I plug in 0?
3.
3. This is going to turn into 0, this is going to turn into 0, and 0 plus 0 plus 3 is 3. Okay, so let's graph it. So negative 1, 1.5, negative 3, 1.5, 0, 3, and negative 4, 3. 0, 3, negative 4, 3. What did I do wrong? Because that don't look right. Oh, I graphed negative 2, negative 1. I should have graphed negative 2, 1, right? Glad I caught it instead of you guys. 'Cause that would have been a donut point.
What would you? Oh.
Okay, so that's what it should look like. Questions? Can I switch to the next slide? Does everybody have the table of values at least?
Hey,
If you'll copy as I'm working, you'll have it. Don't wait till I'm done. Yes.
does it matter like the order under?
It does not. The one thing that I would encourage you to do is always have your vertex in the same location so that you can look. Mine is always.
I have that, I just like put 0 before -1.
Oh, that's fine. That doesn't matter. It doesn't matter. We good now? Yes, sir. Yes, go quickly. Okay, number 4. Still standard form. Still doing the same thing. Okay, so let's see what we got. We got, here's my table of values. Need to find negative b over 2a. So there's the negative in the formula. B, what's b in this problem?
-8.
So b is 8, but with the negative in the formula, it does become -8. And then I've got 2 times a. What's a?
1.
1. Good. All right, so 2 times 1 is 2,
-8 over 3.
which is what?
-0.
Excellent, Bailey. So there's the x value here, and I just plug that in to find the y value. So I got -4 squared plus 8 times -4 plus 15. And then I'm going to work that out. So everybody should be trying it, including you, Trevor, to push this into the calculator to make sure that we can get the correct answer. I know it seems silly. I know you're like, duh, I know how to work a calculator, BZ, but I'm telling you, sometimes you get the wrong thing. And you're so accustomed to just thinking the calculator is going to do the right thing that you don't know to question it. All right, so what do we get?
-33. Wait.
Yes, you did. So -4 squared is 16. This would be -32. So that's -16 plus 15 is going to be -1. That's what we should have got, right? Is that what the rest of us got? So -4, -1. Okay, so what would be the two x values to the right of -4?
-3 and -6.
Excellent. And then if I was going to the left of -4?
-5 and -6.
Very good. And then we just plug these in, right? So we got -3. So everybody should put this in the calculator. Think of it as a race. Try to be the first one to get it right. What did you get?
0.
0. That's what I got too. So everybody else should make sure that they get 0 when they plug this in the calculator. And that means -5 is going to give me 0 too. Well, that's interesting. Now I know that these points are what? They're special. They have a name. What kind of points are they? X-intercepts. Great. Yeah, they have 0 for y value, so they're x-intercepts. They're going to be on the x-axis for sure. All right, let's plug in -2. All right, so make it a race. See if you can be the first person to get it.
3.
3. So let me check you. So 4 plus, this would be -16, so it'd be -12, and 15 is 3. Very good. All right, so let's graph it. -3, 0, -5, 0, -2, 3, and -6, 3. And there it is. Are there any questions on those 4 problems? So all 4 of those problems will work exactly the same way, right? I did the same thing every time. Are there any questions? Awesome. Okay, go ahead and flip over to 5 and 6, and I'm going to give you a hint on 5 and 6. Look at the forms. Tell me what form 5 and 6 are in. They've got 1 parenthesis. So what does that mean? They're in vertex. Yes. I'm sorry. They're in vertex. They will be in vertex on the test. So if it was my study guide and I was the student, I would make a note out to the margins on 5 and 6 that these are in vertex form. Something
Oh,
like
it's
that.
only 5 and 6.
Mhm. What form are 7 and 8 in, as long as we're talking about it? They're an intercept, right? Remember, you're looking at the number of parentheses we've got. 1 parentheses squared is vertex. 2 parentheses is intercept. Right? Okay, so let's graph it.
Hey, I want to know
Just mainly get the table of values. The graph you should be able to do from the table of values. You got it? Okay. So, vertex form is the best to me, because what was the very first thing that I was doing on those last sets of problems? What was the very first point that I found? The what? Somebody said it. I didn't hear it. What was the first point I found? The vertex. Well, if it's in vertex form, I don't even have to find the vertex. It's right there in the problem, right? So that whole first step with the -b over 2a, That's like subtracted out. I don't have to do this. I don't have to do that, right? I just look at it and I know what the vertex is. Who thinks they can tell me what the vertex is? 2 is the x value. What's the y value? 2. Yes, the vertex is 2, 2. So the one tricky thing about vertex form, if there's anything about these that will throw you off, it will be this. So don't let it. I'm telling you, I'm warning you. You know what to look out for. Remember, it's got a minus in the formula in front of the h. That minus just makes things weird. It means when I pull out the h value, it's the opposite of what it looks like it is. So it looks like h is negative 2. But because the minus really belongs to the formula, h is actually just 2. K, on the other hand, the number on the outside, it's got a plus in front of it. So it acts right. It does what it's supposed to do. It behaves. So plus 2, that means K is actually 2, right? So just remember, the one in the parentheses is the opposite of what's here. The one that's outside is exactly what's there. That's the one tricky thing. Okay, so from here to the end, I do exactly what I did on the last 4 problems. I graph the vertex. I find 2 points to the right and 2 points to the left. So what are the next 2 to the right?
3 and 4.
Good, Tasha. And to the left?
1 and 0.
Excellent. And then I'm going to plug in these numbers and see what I get. So I would have 1/2 3 minus 2 squared plus 2. So you should punch this in and see if you can get it. You got 2.5? That's what I got, 2. 3 minus 2 is 1. 1 squared is 1. 1 times a half is a half. And a half plus 2 is 2 1/2. That means both of these are going to be 2 1/2. Okay, let's plug in 4 and see what we get. Let's see what you get there. You got 4. Okay, so 4 minus 2 is 2. 2 squared is 4. Half of 4 is 2. 2 plus 2 is... You are right, sir. So you guys should be checking it. Make sure you get 4 as well. So make sure we're punching everything in the way we're supposed to. All right, so let's graph it. 3, 2 1/2, and 1, 2 1/2. 4, 4, 4, 4, and 0, 4. There it is. Questions on that? So to recap, 5 and 6, it's really like a continuation of 1, 2, 3, and 4, except there's one less step to have to do, right? I don't have to find the vertex, it's right there. Everything else about it is exactly the same. Can I change? Y'all need more time. Going once, going twice, change it. Okay, number 6. Okay, this is obviously in vertex form 2. It's got just the 1 parentheses squared. I'm going to call on somebody. I want to get a random victim to tell me what the vertex is. So take a second and see if you can figure out what the vertex is. Remember, don't be fooled. The minus in the formula means we have to pull out the opposite for the x value. Ah, she's absent. Nancy. Tell me my vertex. Don't forget the minus in the formula. Yes, and?
4.
But this one has a plus, so it's exactly, right?
I got 4.
So negative 4, right? So this is the confusing part. You just got to remember. It's the opposite of this one and exactly this one. So this one looks like positive 2, so I'm writing the opposite. This one looks like negative 4, I'm writing exactly what it looks like, right? If it's in a parentheses, it's opposite. If it's out, it's exact. Okay? You just got to remember, there's no other secret to it than that. Okay, what are the next 2 x values to the right? Don't say them out loud, and call us like that too. Lindsay, what are the next 2 to the right?
Negative 1 and 0.
Good. Montana, what are the next 2 to the left?
Negative
and -4.
Good. Even when he's sick, he still gets them right. Okay, so now I'll plug these in. So I got -1 plus 2 squared minus 4. Let's see what that is. What is it?
-3.
Go, Bailey. Question? Yes, go quickly. Okay, and then we'll plug in 0 and see what we get there. What do I get there?
0.
0.
Oh, you can say that now. Yeah, I get 0, right? 2 squared, 0 plus 2 is 2. 2 squared is 4. 4 minus 4 is 0. So these points are special. What kind of points are these?
X-intercepts.
They're x-intercepts. In fact, this one is so special it's got its own particular name. Origin. Yeah, good. Which means it's an x-intercept and a y-intercept, right? It's both. It's got a 0 in both places. Okay, let's graph this thing. -2, -4, -1, -3, and also -3, -3. 0, 0, and -4, 0. And there it is. Any question about the two intercept form problems? I think if there's anything that will trip you up, it's that sign. So just when you're studying tonight, just make sure you know to pull out the opposite of the one in the parentheses, right? Because if for some reason I just had a brain fart and I pulled this out as 2, well then that would throw off all these numbers, right? And so my graph would look completely messed up. That one mistake would mess up everything else. And I wouldn't realize it until I plugged in these numbers and started getting weird things here, and I'm like, this doesn't look right. And then I would realize. So you would do a bunch of work for no reason. So just be careful. Yes, sir?
So number 6 is vertex form?
Yep, 5 and 6 are in vertex form.
Oh, 7 is
I'm sorry. 7 and 8 are in intercept. So let's do them. Does anybody need more time? Yes, sir. See what's right here? The origin, where the two things cross, right? Okay, 7 is in intercept form. What is my clue? It's
2 parentheses.
the 2 parentheses. Okay, so intercept form is the most confusing to most people. It is for me. It's the hardest for me. Although I've had a few people today tell me they really like it. The one nice thing about it is, in standard form, I get nothing for free. I have to work to get anything I want in standard form. In vertex form, I get one thing for free. I get the vertex, just by looking at it. The nice thing about intercept form is I get 2 things for free. I'm going to get 2 points for free. So make table of values, just like before. It's going to tell me the 2 intercepts, right? I get 2 points, one from this parentheses and one from this parentheses. The tricky thing here is this formula has minuses too. So that means when I pull these points out of the parentheses, they're the opposite, right? So that means that one of my, what is the x-intercept I get from this parentheses?
-3.
Good. And from this one?
Positive 1.
Okay, now, you'll notice where I put them. I like to put them there so that I can leave room for my vertex here and for my points in between here. I don't really care what order you guys put these in. I'm not really grading this, I'm grading this. But it would probably be best if you do it the same way as me. I strongly recommend you to keep your vertex in the same place regardless of what form you're working. And you'll notice mine is always in the very first spot. That way, if I ever look at a table of values I've done anywhere, I know that that first thing I'm looking at is going to be my vertex every time. This is easy. Okay.